Hi everyone. Today I will be giving a talk on the observability for LLMs. This talk is about a very practical question. Once we put LLMs into real world systems, how do we operate them reliably? Most of us in this room are familiar and have a very strong mental model about observability and how to monitor metrics such as latency, error rate, resource health, etc. That knowledge is helpful, but when your core dependency of the system is a model, the entire shape of the system changes. Today, I will be going over a practical model on how to observe these systems, what key signals that we need to monitor, what new failure modes show up, and lastly, how can we start building an observability stack for those systems. So why does this matter now? Increasingly, LLM systems are moving into real-world systems and out of experiments. So products like support systems, co-pilots, search, and user-facing products are increasingly being powered by LLMs. However, the teams are still monitoring them using traditional service dashboards, and that creates a blind spot. A request can be successful. However, the model output can still be incorrect, can be unuseful to the user, or can be unsafe. And it does not even show the whole picture. Like, for instance, did the model call the right tool? Did the model got the right, did we retrieve the right context, right documents to answer the user question? So the key mental model for LLM applications is to observe the entire workflow, not just the endpoint. So let's talk about how an LLM application actually works. Usually, people think of LLM applications as user sends a request and the model responds with an answer. However, a more realistic workflow looks like the following. User sends a request, the application creates a prompt, it may also create embeddings, it may retrieve relevant documents from using a vector database, searching through a vector database, and then it may re-rank those documents. Then it sends the prompt and the relevant context to the model. The model may decide to use a tool. Another model may be called to construct the answer. The app then formats the response, and then the app might run evaluations and safety checks before returning the response to the user. So the backend workflow is complex. So what is LLM observability? I like to define it as classical observability plus AI workflow visibility. So we still monitor the traditional metrics like latency, errors, availability, throughput, but we also monitor additional metrics such as model calls, token usage, cost, retrievals, tool calls, and also semantic health metrics like quality signals, safety check, grounding score, usefulness through user feedback. So operational health focuses on, did the application run, did it return, did it run fast? Whereas semantic health focuses on, did the application give the correct response? Was it following the policy? And was it answering based on the context? So how is LLM observability different? So firstly, a 200 response only shows that the transport path was succeeded. However, it does not really show if the output was correct, was it useful to the user. Secondly, work now scales with token as well, not just a request count. So two similar requests, two requests can have different amount of work. One request can be tiny and can just be a direct answer from the model. The second could be multiple tool calls, multiple model calls to basically construct that answer. Thirdly, streaming changes the latency. Since these applications are usually streaming oriented, so instead of just looking at the end-to-end latency of the application, usually in these type of applications, the time to first token matters more and has a higher impact on user experience. Fourth, the pipeline, it's a complex pipeline as we went through earlier. These are a series of long chains of calls, and it's not a few API calls like we used to have in conventional applications. And lastly, the same endpoint can trigger many different workflows. So this is especially important for us as in SREs because in traditional applications, if you are tracing multiple calls through an endpoint, those usually follow a similar path. Whereas in an LLM application, those multiple requests can have very different paths and very varying paths. And that leads to complexity. So I will go over a practical example of what we learned at TikTok. Initially, we were monitoring the LLM application as a conventional application using traditional service metrics, like monitoring like request rate, latency, error rate, and resource usages. The service health usually looked healthy. However, user experience told a different story. And we observed that there was inconsistent quality, unexpected costs, and unpredictable behavior, workflow behavior. And we quickly realized that we were missing key metrics such as token usage, time to first token, retrieval behavior, tool success rate, finish reason, and quality signals. So this slide basically shows how a classical service might be arranged. So for instance, a classical service would be something like there is a user request, it goes to the backend, and the backend basically compute or does follow, or basically does the application logic, and then that request flows to a database. And then once the database call is returned, the response is returned to the user. However, as we discussed earlier, the LLM application has a long chain of steps that it has to go through. And that also leads to unpredictability into LLM applications. So what are the sources of unpredictability for LLM applications? So the first is the tokens are generated through a probability distribution. So each next token is the model uses probability distribution and basically tries to find the token with the most highest probability. That means the same input can lead to different outputs. Secondly, small changes in prompts can lead to highly variable outputs. Thirdly, two requests can have different context and different documents being injected into the prompt, and that could be due to because the vector database search is actually a nearest neighbor search. So you can't. So it is not really deterministic. Fourth, as conversations get longer, a context window increases, and this leads to higher memory usage, higher cache usage. That can also lead to increased risk of truncations, and that could lead to applications performing unpredictability. Lastly, the underlying model or the provider changes could lead to unpredictable outputs. So I like to basically divide the observability of LLM applications into 4 layers. The first is user experience, what the user actually feels. Second is models and tokens. Basically, what did the model do and how much work it had to do. Retrieval tools, what context did the application require to basically build the answer. And lastly, infrastructure and serving, what happened in the underlying hardware while generating the response. So let's look at the first layer, user experience signals. So in this layer, we focus on these key metrics: end-to-end latency, time to first token, time per output token, success rate, user feedback, retry rate, and abandonment rate. The key over here is that in streaming systems, time to first token is highly important to measure, and not just end-to-end latency. Second layer is model and token signals. In this, we measure token usage, cost per request, finish reason, model provider underlying, prompt version, and number of model calls per request. So this layer basically focuses on observing tokens. So we, instead of thinking of in terms of requests, we start thinking about tokens in this layer. Third layer is retrieval and tool signals. It focuses on the key signals for this layer is basically retrieval latency, empty retrieval rate, retrieval doc count, tool success count, tool success rate, tool latency, etc. So this basically gives us a picture that the model might not be the problem. It could be the retrieval flow that might be the problem. So often a bad output can be, a model can be blamed for that. However, it could be, the bad output could be due to empty retrievals, no appropriate documents being fetched. So those could also be the reasons for a bad output. So the last layer is basically infrastructure and serving signals. So this basically, so the key signals for this layer is basically focuses on resource and node server metrics. So for instance, GPU utilization, GPU memory, KV cache usage, queue time, waiting request, running requests, node health. So a lot of times user experience signals will give us what the user actually experienced. However, it might not show why it really happened. And this is where these signals help in basically figuring out what really actually happened and that might have caused that. So putting the layers together. So for instance, if we observe a rise in latency, that could be due to the prompts might just have gotten bigger, retrieval might be slower, or there might be lots of requests being queued. Another example could be we observe a drop in quality. That could be due to the retrieval might have weakened, the retrieval score might have dropped, truncation might have increased, tool failure rate might have increased, or the underlying model might have changed. The cost for a few reasons for rising cost could be growth in tokens, extra model calls, or prompt bloat. Throughput drop can be due to increase in traffic, increase in context, or GPU memory pressure. So when instrumenting LLM workloads, we should not just instrument the model call, the request to the model and the response. We should trace the entire workflow. So like as we discussed earlier, going through all these steps, the prompt construction, retrieval steps, model call steps, and then the response construction steps and evaluations. And for the entire trace, we should attach metadata such as model name, provider, prompt version, the route the request took, the tenant, and retrieve docked IDs. So this is how a good trace should look like. It should show the entire story of the request of how, so basically over here, instead of just monitoring the endpoint, we are monitoring the entire flow of the application. And since the LLM applications take different paths, it is extremely valuable for LLM applications to monitor traces, because when debugging these systems, it is the traces matter more than, because the request can take different paths. Let's talk about safe logging. So by default, we should log metadata and counts. So for instance, token counts, model, identity, prompt version, document IDs, finish reason. But we should be careful when logging raw prompts, raw completions, sensitive user data. We should employ sampling and redaction to ensure that we are not logging sensitive user data. So app signals focus on user experience, but we also need to correlate those signals to GPU or infrastructure metrics. And the way we correlate these app traces to resource and infrastructure signals is through common labels such as service, pod, namespace, node, model name. So let's go over some example incidents. So for instance, in this case, the system experienced a drop in quality, and the user complaints started to increase. However, we observe that the error rate is completely normal. But digging deeper, we realize that GPU memory usage has risen, cache usage has increased, and the number of waiting requests has also increased. So the fewer documents are being fit into the requests, and more responses are basically being truncated. As a result, the user the quality score has dropped for the application. So this is a very AI kind of specific incident. The model did not suddenly become dumb. The workflow degraded with increasing pressure. Secondly, another example is basically the request rate is stable. However, we notice throughput drop and time to first token increase. And digging deeper, we realize that the number of input tokens per request has increased. Sessions might have gotten longer, or more documents were attached to the requests, leading to higher cache usage. And as a result, the concurrency dropped, leading to lower throughput and increasing latency. So in LLM systems, bigger requests often hurt more than more requests. So some of the practical metrics and alerts that we should have for LLM applications is time to first token rising. The queue, the number of requests waiting in the queue, the GPU memory being near limit, tool success rate dropping. Other things that we should watch for regression are input tokens per request, empty retrieval rate, finish reason length increasing, and quality score dropping. So an observability stack that a simple observability stack that can be built could be, so for instance, for monitoring application traces, we can use OpenTelemetry standards to Gen AI metrics standards to basically observe traces. And we should observe the entire workflow rather than just the model call. Second is we can monitor metrics such as time to first token, time per output token, queue time, model metrics through VLLM metrics. For infrastructure, we can monitor GPU metrics such as utilization, memory through DGCM exporter. For quality, we can run lightweight evaluations and also monitor user feedback. And we can combine these all these signals using Prometheus and dashboard them using Grafana or any other vendors that you might be comfortable with. So the mental model for LLM applications is, so we have traditional observability where we focused on, is the application up, is the application fast, and is it error-free? But LLM observability also includes, did the workflow behave correctly and in an expected manner? Did it answer well? Did it stay efficient? And did the serving and infrastructure layer support that outcome? So at the end, I would like to end with the 3 key points that for LLM applications, we need to observe the entire workflow, not just the endpoint metrics. Tokens, retrieval, and quality are first-class signals here. Thirdly, we should combine app traces with model server metrics and GPU telemetry to get the entire picture of the request. This will help in debugging the incidents that you encounter. So this is all I had for today. Thank you.